Good evening. My name is Orion Houndstrup, and welcome to my project on the NFL. Most notably, it is my NFL player career predictive project. Gosh, I'm really excited to show you guys the results. I'm thrilled at the progress, and it's been a long haul, and I love the final results. So let me give you a little demo. Before I say anything else about the project, a statement of purpose. Why? Why this whole NFL thing? Sure, I'm a football fan, as you may have noticed. But more relevantly, it was actually at this very table that I'm sitting at, where over, I guess we could call it a family dinner, I live with a few friends, a discussion was had. And one of the things that makes me love football in my house is that each of us in this whole household roots for a different team. We've got a Patriots fan, a Bills fan, a Chiefs fan, all kind of Jags, Green Bay Packers. And the Bills fan was making this speech about the fact that Josh Allen has all the time in the world to win a Super Bowl because he'll play well for the next 9 years. Everybody else in the whole room sort of looked at each other, obviously disagreed with that. And we began having this back and forth about the future of Josh Allen's career. And my own opinion, I didn't think he was going to play that well for that long because he's a running quarterback. They have a lot of injuries and all of that. Anyhow, I began to notice over the course of the conversation that it was all just emotions and bravado and passion about one's football team. There was there's nothing to grip onto. There's no science being used. There was nothing objective about it. And just in the back of my head, over the next year, I started pondering, is there a better way to answer that than just arguing with each other over beers with nothing? Is there evidence? Is there science? Is there an actual scientific method that one could use to answer that question? And in the particular way that I think, as a mathematician and data scientist, I just couldn't stop wondering, in my spare time, if I ever had the time, could I design a machine to help predict numerical and objective answers as to what the future of Josh Allen's career would look like? And thus began the core initial spark that led to this project. Way too long a story. I designed a previous version of this machine for a former class. Clicking down here, the NFL project. In the intro are a few pictures of how the previous version of this machine worked. I managed to. Here's an example of it. I'm trying to keep myself on the screen if I can. Here's an example of the previous version of the machine. Taking the actual player, in this case Kurt Warner. This is how he actually played, and here is how my machine predicted that he would play. This is the purple. This machine, frankly, did a pretty okay job predicting a lot of the players. That being said, the dream in this project, in machine learning, was how much better a version of this machine could I create? Would it be possible to make better and better versions of the machine using more and more advanced machine learning tools? And I found that fascinating, and I've been dreaming it for a long time, and it's been such an honor and a pleasure to be able to have the time to examine that scientifically. So here we go. Take a little deep dive. Sometimes my camera might freeze. I'm just using photo booth here. We'll try. So, key questions in the whole project are listed here on the intro page. What to be done with the corrupted and missing data, all kinds of interesting things. I'll let the readers read that at their own best time. But other key things in the research, let's say I created many, many different versions of the machine. Would one of them take first prize for both how long a player will play for as well as how well they'll play? Or will those be two different machine learning models? Are we going to have two winners for two different prizes, or will there, in best case scenario, be a single machine learning built version of this machine that takes the prize overall and gets the best in both worlds? So anyhow, moving on. First thing to do was to actually gather all the data, whole big long project building scrapers and actually gathering all of the data from various internet sites. Right now, the active version of the project mostly comes from the NFL statistics pages themselves, which has great quality data from 1970 and beyond. Someday, specifically with SMV, support vector machines, I want to add in all the data that I did scrape from the 1940s and thereafter, just to see if adding that old historical data will actually make the engine more accurate or not. I'm very curious. Moving on. A lot of work there. These are some spit out trajectories of random players, my favorite of which is the really, really zoomed out one that has all the players who've ever played football in one great chart. I found it's a little like staring at the cosmic microwave background radiation. Okay, so when it comes to, before we can even look at all the different versions of the machine, really the dream, the core dream at the kernel of the entire project was, since I already had a version of the predictive machine, could I evaluate it numerically? Could I come up with a methodology by which to actually test how good a predictive engine I designed? Because no point in making this thing if I can't see if it works. Like, I wanted to have an objective, better than just my own eyes and testing a few players. How well a prediction does it make? Way too long a story. I managed to come up with a way of actually acquiring that info. And the original version got these scores, and then I moved on, whole other versions. Anyhow, the short version of that is that each version of the machine now had a way of being scientifically tested for its efficacy. K-means clustering was run, which ended up at first really not going that well. And I'll get right back to you on why. Hierarchical clustering was then run. This machine worked actually the most poorly of any of the ones in this entire project. Skipping ahead a little, the problem was that NFL players have quite varied different career lengths, and there was just no way to properly, according to the traditional way of using k-means or hierarchical clustering, there's just no good way, as far as I know, of using those two machine learning tools with vectors of various lengths. I'm going to skip ahead just a little. I came to call this the jagged cube problem because it meant that one edge of the data cube is of completely variable chaotic lengths. And I managed to solve that problem. It might be my greatest achievement of this whole project, is I figured it out. Figured it out in the shower one day. Jagged cube problem. I managed to actually, the loss is I managed to come up with a mathematical answer for it that destroys the runtime. This became much, much, much slower, but it meant that for each and every different individual player examined, you have to retrain the model. That being said, I came up with a solution, a way of actually straightening that jagged edge of the cube, and with that, k-means clustering still didn't break the original record, but came a lot closer to it. I was pretty proud of this one. Considering the earlier version of k-means and then this solved one, dramatic progress. Moving back. PCA is another fascinating machine learning tool. I will bore you telling you stuff you already know if I describe it to you. Very, very interesting though. And I love the fact that it's a way of taking a massive, chunky data set and cutting it down to size by keeping only the most principal components. Very, very, very interesting stuff. Once again, I required the solution to the jagged cube problem. Managed to actually make that work. And once again, got a result. Nothing all that exciting. The goal was, would it, in the simplified version, actually get better predictive ability by reducing the noise? And no, the answer was all that nice little extra noise, the 1,500 statistics, were relevant. They were needed for the predictions. I'm surprised, though, that it got as good a prediction as it could with such a simplified data set. But fascinating stuff. Next up came a part of the project that I still believe in. This didn't ultimately work out very well at all, to be honest. But I believe that with much deeper thought, proper implementation, I believe in this part of the project. The goal was run the machine, look at its outputs, look at when it succeeds, look at when it fails, and carefully catalog those. Do a lot of very deep and extensive science of when does it fail, why does it fail, and can we predict when it will fail. And I ended up using decision trees for this analysis. Way too long a story, but the decision trees ended up taking each player position and analyzing when did they succeed and when did they fail and by how much, and trying to preemptively nudge the predictions in the right direction. Really, really interesting stuff. I was 100% convinced that this was going to not only produce better results, I was worried it would produce such better results that it would be the dominant machine learning tool used in the whole project, and it would be kind of like cheating by, oh my god, what have I done? Sorry about those balloons. I have no idea what just caused this. Truly sorry about that. Anyhow, I really thought that these would improve the model. And I additionally thought the problem would be decision trees have a tendency to overfit for the data. And I thought that that would be the new nightmare. They actually didn't improve the model, with very, very careful and nuanced and subtle usages only used for quarterbacks with short careers, or what was it? I think it's running backs with long careers. I gave very gentle nudges to only certain players and technically did produce a better result. But nonetheless, even though this kind of failed, the core idea of trying to predict the predictions I find fascinating. It's getting very meta and like a loop within a loop within. recursive reasoning, how can one predict when the predictive machine will succeed and when it will fail, is a fascinating idea. And I'm not, even though this failed, I'm not at all convinced that the whole idea wouldn't someday work. Now we get to a really exciting result. Support vector machines actually gave the best version of the predictive engine. Support vector machines are fascinating, higher dimensional, involved means of classifying data. The core breakthrough here, and I really thought that this was going to produce adequate results at best, was support vector machines are a tool for classifying data. They're not used to predict the future of a vector of some sort. And I mean, they're not like a physics-based predict where the cannonball is going to fly in Physics 1 kind of thing. And yet I managed to make a recursive system of predicting using them. Way too long a story, but would the player retire the next year? If not, how well would they perform? Classifying them into different bins, and then recursively loop that. Pressed go, again, assuming that that would not go well, and was just startled by the fact that I actually got the best results yet in the whole project. Each of these worked really well. I will privately admit polynomial kernel took so long to load. This was the worst run experiment of the entire project. I think you could break a computer trying to run those. Maybe I did something wrong. I really streamlined the code, and these were so slow. Oh my god, you could watch paint peel faster. But radial kernel was the new winner. Last one up, neural networks. Fascinating, the most complicated of the machine learning tools in this project. I really enjoyed working with these, but in the end of the day, the trouble is they really seem, as far as I understand, designed to work with big, chunky data sets. And the way that I ended up having to use these was to pare it down to just players of a given number of years. And when you're looking at trying to predict the end of Tom Brady's career when the man's been playing for 20 years, there's so few players to use as training data to even answer the question of how well will the rest of his career go. Neural networks just simply didn't end up working out. I respect them. I admire them as a tool. They were clever. They produced really not great results. Moving ahead. All that can be pleasantly summarized by one big picture. I love this. This is literally my favorite part of the entire project. This is the results. This is every single one of the classification predictive engines that I designed for this project. This one right here was where we started. This was the very first predictive engine. These were the early improvements. And this one right here, nearest neighbors using median, very simple. I had that on the first week of this project. It was really hard to beat. That one literally held the title for a long time. And even decision trees only barely managed to beat it. Support vector machines did manage to slightly blow it out of the water. They ran significantly better. But for the longest time, though, everything I tried was simply worse. It was like an old hat, new hat. So it's just the first one was just the best one. Very interesting. I love having this final picture as a summary of everything that was done. It's great. And I'm really proud of how, considering that we started here, we managed to nudge it all the way to there. It worked pretty well. Here are some examples of the final code. Feel free, by the way, there's a link right here to that final code. Feel free to play with it yourself. I'll give you a few demos of how it works before I go. It is really fun. I decided to not just show the best one. I left partially because I find it very artistically satisfying, the nearest neighbor mode one with those nice little purple boxes, the bins. I additionally showed the decision tree one right there. Well, the gentle version of the decision tree, the full one didn't work as well. And then finally, the winner, if you will. And so you'll find the best prediction is this SMV one. Note, however, that just by my eyes, it does seem to over-predict the player's retirement by a good deal. Maybe it's because I'm continuously, for these images, looking at players whose names I know, and maybe for like famous long-careered players, storied players, it over-predicts their careers. Somehow, in the data, it's the winner. Maybe it consistently gets short-careered players accurate and fails on these. Either way, anyway, by visual assessment with my own eyes, the decision tree one seems to be the best model. But I really love, in blue are the nearest neighbors scattered all over the place. In purple are those nearest neighbors binned, and then you use mode to establish the predictions. And you can see this was the original prediction, and the more modern machines did better, especially the decision tree one's pretty spot on. Once again, we got Dan Bailey, a nice kicker going. The predictive original version of the engine had him playing reasonably and then just falling off and retiring. And the other two slightly overpredicted his career, but not really. They vary, they cluster around the truth, but we can see that we have significant improvement over the original base engine. And then finally, our boy Malcolm Butler, woo, Patriots, Mr. Malcolm Butler himself, the machine simply capture his career trajectory. I typed in his name randomly just for a sense of sentimentality about the man, and I was kind of, as the last example, that was pretty good. I mean, sometimes it's easy predicting a player's career. If they play pretty well, they'll probably continue to play pretty well the next year. But nonetheless, there's a beauty to this machine. Let me give you a single little demo of this in action before I go. I don't know if you can still see my screen. Let me try to bring this back over. Yep. Sure. All right, and just for fun and for scientific authenticity, let's run this on some players we've not yet examined. Let's do a quarterback. I'm going to go in for historical. Let's choose a random one. Todd Collins. How about we examine how his career would look given the first 9 years of training data? We see that he actually played this. The original base engine thought he'd play 2 more seasons and retire. The decision trees thought he'd go for about 2 more years, and SMV was the closest one, and was pretty far off in how it really overpredicted how well he'd play, but still, nonetheless, all these are good fun, and they're not perfect, but nonetheless, according to the data, they do get to within plus or minus 1.5 years of retirement, and realistically to about 10 to 15% within truth. Let's do one more player. How about a wide receiver? Let's do Jerry Rice just for fun. We need to select. There might be a bunch of these guys. Sorry, I forgot about that. Patience required. 1 sec. Jerry Rice. Okay, let's give it the first 5 years of his career. Let's see if any chance that it predicted he'd last a long time and play really well. All the models actually did predict the next part of his career pretty well. I guess no one's surprised to hear that the part of Jerry Rice's career that surprised everyone was he played brilliantly forever. I didn't know he had a bad year. Was he injured? Interesting. Anyhow, I love playing with this tool. It's really fun. Feel free to play with it yourself. And it finally leads us to the analysis of Josh Allen's career. At the time of this filming, I have not yet made it be able to predict future players with all 3 tools. I'm going to work on that in the next 15 minutes and get it finished. I'm having a technical bug. But to answer the original question, how long will Josh Allen play well for? All the predictive engines in the world agree with me. My friend who's a Buffalo Bills fan saying he's going to play well for 9 more years. Finally, I wouldn't be a jerk and say it to him, but I have scientific evidence of a sort, to say scientifically he's wrong too. That Josh Allen, according to this research, the machine thinks he's going to play reasonably for 3 more seasons, terribly for 1, and then retire. And the core of this whole project was to have some fun with machine learning, practice these tools, and really answer a philosophical question of can one be scientific about something so ethereal in short as predicting the future. Using the limited historical info available, can one predict the future of something as chaotic and unpredictable as the future of a football player's career? I was actually kind of startled. The results are pretty reasonable. There's always outliers. I'll always think of Mr. Tom Brady himself towards the end of his career, really trying to sort of swim upstream because all the data in the world said he'd start playing very badly and retire. And yet he went on to win more Super Bowls. So sometimes data analytics get in the way, especially of an outlying player like Jerry Rice or Tom Brady. But nonetheless, it's been fascinating. The whole project's been a lot of fun. I'm thrilled by the results, and feel free to play around with them yourself. It really is a fun tool, and I thoroughly enjoyed learning a lot on this project. All right, to one and to all, good night, and good luck to your football teams.